Download this code from codegive.com, link in the description below. September 2016 DevTest Community Webcast, DevTest and Selenium, a comprehensive tutorial. The September 2016 DevTest Community Webcast focused on the integration of DevTest, now known as Broadcom Virtual Service Management, with Selenium for automated testing. This combination allows for powerful capabilities like virtualizing services, creating realistic simulations of dependent services that are unavailable or unstable, ensuring reliable testing. Performance testing, simulating load on the application being tested by leveraging DevTest's performance testing features along with selenium-driven user scenarios. End-to-end testing, orchestrating complex workflows involving multiple applications and services, ensuring comprehensive testing. Data-driven testing, using DevTest's data-driving capabilities to dynamically generate test data for Selenium tests, improving test coverage. This tutorial will cover the key concepts discussed in the webcast, along with code examples to illustrate the integration. Understanding the components. Before diving into the code, let's understand the core components involved. DevTest, Broadcom Virtual Service Management, a suite of tools for service virtualization, performance testing, and test data management. The key components used with Selenium are DevTest Portal, the central web-based interface for managing and configuring DevTest. DevTest Workstation, the integrated development environment, IDE, for creating and managing virtual services, test cases, and data sets. Enterprise Dashboard, a central monitoring and reporting tool. Simulators, vs Image, a virtual service that mimics the behavior of a real service. Created and configured in the DevTest Workstation. Selenium WebDriver, a popular open-source automation framework for web browsers. Allows you to programmatically interact with web applications. Your application under test, the web application you are trying to test. Dependent services, the backend services, APIs, or databases that your AUT relies on. These are the services you might want to virtualize. 2. Scenario, testing an e-commerce application with virtualized payment gateway. Let's consider a common scenario, testing an e-commerce application. Specifically, we'll focus on testing the checkout process, which relies on a payment gateway. In a real-world scenario, the payment gateway might be unavailable, have performance issues, or be too expensive to use for testing. Here's the outline of our test scenario. 1 user adds items to their shopping cart. 2 user proceeds to checkout. 3 the application interacts with the payment gateway to process the payment. 4 if the payment is successful, the user is redirected to an order confirmation page. 5 if the payment fails, the user sees an error message. We will virtualize the payment gateway using DevTest. This allows us to test the application's behavior with different payment gateway responses, success, failure, timeout, without actually interacting with the real payment gateway. 3. Steps to integrate DevTest with Selenium. Here's a step-by-step guide to integrating DevTest with Selenium for this scenario. A. Creating a virtual service in DevTest. 1. Identify the payment gateway interface. You need to understand the communication protocol used by the e-commerce application to interact with the payment gateway. Common protocols include REST, SOAP, or JMS. You'll need to know the request and response message formats. To record the payment gateway interaction, optional, use the DevTest recorder, part of the workstation, to capture real traffic between your application and the payment gateway. This provides a realistic basis for your virtual service. If you don't have access to live traffic, you can manually create the request/response pairs. 3. Create a virtual service, VS, image *, open the devtest workstation and create a new VS image. Choose the appropriate protocol, example HTTP/REST, SOAP. 4. Define the transactions * for each transaction, example process payment, define the following. Request matching * define criteria to match incoming requests to this transaction. This can be based on the request URL, headers, or body content. For example, you might use a regular expression to match the URL. Response definition * define the response that the virtual service should return. You can create multiple responses for different scenarios: success, failure, timeout. 5. Implement response logic, optional. Use devtest scripting capabilities, example Groovy scripting, to dynamically generate responses based on the incoming request or other factors. This allows you to create more sophisticated virtual services. For example, you could simulate different error codes or delays based on the amount being processed. 6. Deploy the virtual service * deploy the VS image to a devtest simulator. You will get an endpoint URL for your virtualized payment gateway, example http://localhost1505/payment gateway. B. Configuring the application to use the virtual service. 1. Modify the application configuration * update your e-commerce application's configuration to point to the virtualized payment gateway endpoint instead of the real payment gateway. This might involve changing a URL in a configuration file or database. C. Writing Selenium tests. Now, let's write some Selenium tests to interact with the e-commerce application and verify its behavior when using the virtualized payment gateway. Explanation of the code ***. Setup, ***. This method initializes the Selenium web driver, using Chrome driver in this example, sets the base URL of the application, maximizes the browser window, and creates a WebDriver wait object for handling asynchronous loading. Important ***. Make sure you have Chrome driver installed and the path to it correctly set in the system.set property, line. Test successful checkout, ***. This test case simulates a successful checkout process. It adds an item to the cart, goes to checkout, fills in the checkout information, submits the payment, and then verifies that the order confirmation message is displayed. This assumes that when devtest is set to return a successful response, the application will behave as expected. Test failed payment, ***. This test case simulates a failed payment. Before running this test, you must configure the devtest virtual service to return a failure response. The test follows the same steps as the successful checkout test, but instead of verifying the order confirmation, it verifies that the payment error message is displayed. Teardown, ***. This method closes the browser after each test. Data driving and virtualization for more complex scenarios. The example above uses hard-coded data for the checkout process. To make the tests more robust and cover a wider range of scenarios, you can use devtest's data driving capabilities. 1. Create a data set in devtest * in the devtest workstation. Create a data set that contains different values for the checkout fields, name, address, credit card number, etc. You can create multiple records in the data set to represent different test cases. This dataset can even simulate different return responses from the virtualized service. 2. Bind the dataset to the Selenium tests * use devtest's APIs to retrieve data from the dataset and pass it to the Selenium tests. This will allow you to run the same Selenium test multiple times with different sets of data. Explanation of the data-driven example asterisk. Asterisk data driver asterisk. This class is the core of devtest's data driving API. It allows you to connect to a data set and retrieve data row by row. You need to include the appropriate devtest client libraries in your project to use this API. The commit.co.lisa.test.datadriver package is from the Lisa client jar, often Lisa client-star.jar in your devtest installation. Asterisk setup, asterisk. The setup method initializes the data driver object. You need to provide the name of your data set and optionally the name of your test case. Replace checkout data and checkout test with the actual names you used in devtest. Asterisk test checkout with data, asterisk. This test method iterates through the rows of the data set using the data driver has more rows, and data driver next row methods. For each row, it retrieves the values for the checkout fields using rowdata.get parameter value. The expected result, success or failure, is also retrieved from the data set. Based on the expected result, the test verifies the appropriate message is displayed. Asterisk devtest response asterisk. This parameter from the dataset represents what action you will do in devtest to simulate the various responses. For example, one value may be slow connection, in which case you will configure the VS images request response pair to return a response with a delay. Another may be credit card invalid, in which you configure the VS image to return an error code /fault indicating an invalid card. Asterisk important asterisk. Remember to configure your devtest VS image to align with the devtest response values you are injecting from the data set. 4. Advanced techniques. Asterisk performance testing with devtest and Selenium asterisk. Use devtest's performance testing features to simulate a large number of users interacting with the e-commerce application through Selenium. This allows you to measure the application's performance under load and identify potential bottlenecks. Asterisk using devtest assertions asterisk. Incorporate devtest assertions into your Selenium tests to verify that the virtual service is behaving as expected. For example, you can verify that the virtual service is returning the correct response based on the incoming request. Asterisk correlation asterisk. When recording traffic with devtest, you might need to correlate dynamic values, example session IDs, timestamps, to ensure that the virtual service returns the correct responses. Devtest provides correlation features to automatically handle these dynamic values. Best practices. Asterisk start simple asterisk. Begin with simple virtual services and gradually increase the complexity as needed. Asterisk use realistic data asterisk. Use realistic test data to simulate real-world scenarios. Devtest's data generation features can help with this. Asterisk version control asterisk. Store your virtual service configurations and Selenium tests in a version control system. Asterisk automate everything asterisk. Automate the entire testing process, from deploying the virtual services to running the Selenium tests. Asterisk monitor your tests asterisk. Monitor the execution of your Selenium tests and virtual services to identify any issues. 6. Conclusion. Integrating devtest with Selenium provides a powerful solution for automated testing. By virtualizing dependent services, data driving your tests, and leveraging devtest's performance testing features, you can ensure the quality and reliability of your applications. Remember to consult the official devtest documentation and the Selenium documentation for more detailed information. The 2016 webcast recording and materials, if available, would also provide valuable insights. Good luck.